Hello and welcome. In this video, we are going to discuss how to conduct data envelopment analysis in R. More specifically, we will be discussing CCR model of data envelopment analysis, or DEA as it is commonly called. Although for the purpose of this video, it is assumed that you already know what data envelopment analysis or DEA is, but to give a very quick idea, data envelopment analysis is a technique which is used to evaluate relative efficiencies of various decision making units of an organization. Decision making units, or DMUs as they are commonly called, are distinct subunits of an organization which are independent with respect to some of the decisions they make. For example, if a bank has 10 branches, those 10 branches are its decision making units. And as you know, for managerial reasons, we often need to evaluate the efficiencies of various DMUs in order to be able to see which branch is not performing well and which branch is performing well. Not only that, but we also need to know for making managerial decisions what level of inputs or outputs we should be targeting for every subunit or DMU. So, data envelopment analysis helps us do just that. It not only evaluates the relative efficiencies of various decision making units, but it also gives us some idea about what level of inputs and outputs we should be targeting for every DMU. Okay. There are various models of data envelopment analysis which are in use, but the first model to be developed was this model called CCR. It is called CCR because it was developed by Kohn, Cooper and Rhodes. So, Kohn, Cooper and Rhodes, CCR. It was first developed in 1978, and although a number of new models are now available, this is still a very useful and very popular data envelopment analysis model despite some of its shortcomings. So, we will be conducting a CCR analysis in R using a package called DEAR. So, but before that, let us discuss what CCR model is. CCR model is an input oriented model, that is, it seeks to minimize inputs for a given level of outputs. One. And the second thing about CCR model is it assumes a constant return to scale, which means that it assumes that for an increase in inputs, there is a constant increase in output as well. For example, if we increase 1 unit of input and 0.5 units of output increase as a result, then if we increase 10 units of input, 5 units of output also increase. So, the rate of return is constant on scale. If we increase 1 unit, it always results in an increase of 0.5 units in output. Although this is a faulty assumption in many cases, that is why we have new and more models which do not make this assumption of constant return to scales. Rather, they assume variable return to scales. But this is not always a faulty assumption to be made, as in many cases actually rate of return is constant. Okay. Coming back to the package we are going to use in this video or for conducting this analysis is called DEAR. It is a very good package, and first let's install this package. To install a package, as you know, we write install.packages, then we write the name of the package, DEAR. DEA is small while R is written as capital. Okay, I have given the command of install.packages. Now it is installing the package. Okay. The package has been downloaded and installed in my RStudio. Now what I need to do is to call this package, and let me write require. But before that, let's import the data we will be working with. To import data, you go here, okay, import data set, and I have data set in Excel, from Excel, and I will give it the path where I have saved that, and it is here, CCR data file. Okay, we'll be saving with the same name, CCR data file, and we are not going to skip any of the columns, and I click import and it is imported. So you can see it here that these are various DMUs. This could be anything, number of branches of a bank or departments of a university. I have 2 inputs. That is not important which these inputs are. This could be number of staff and area of the department, or number of staff and the utility bills of a branch of bank, and then I have outputs. This is again not important. This could be anything from number of bank transactions performed per employee to number of profits made, the level of profit made by a bank branch. Okay. So if you see, I have 10 DMUs, 2 inputs and 2 outputs. Okay, O1 denotes output 1, O2 denotes output 2. Okay. Now let's call the package. I'll write require. You can also write, I'll require DEAR, and DEAR package is loaded. Loading required package DEAR, and this tells us was built under version this, etc., etc. So this package has now been loaded. The thing is that I need to transform this data into a form that is understood by this package, and because this is the raw form of data, this package or R cannot work on it for the purpose of data envelopment analysis. The first thing I need to do after importing my data set is to adapt this data to this package DEAR. To do that, we use this function, read underscore data. Okay, and in this we specify, but let's save the result of this data, CCR model, CCR model. Read data. Which data? Which I have as CCR data file, CCR data file, and I will have to tell R how many inputs and how many outputs are there. So number of inputs Ni is 2, number of outputs No is also 2, and I also need to tell it where the names or numbers of DMUs are, because this column DMU does not represent any of the input or output. These are just the numbers of different DMUs. These could also be names. So I need to tell it DMUs are in column number 1. And then I need to tell it where inputs are. Inputs are in column 2 and 3. So column 2 to 3, and outputs are in column 4 to 5. Okay. Just see what happens when I execute this command. Okay. This CCR model has been created, and you can see that it is a list. What is there in this list? You can also see, if you click this, you will see the description here. It is a list of 9, 3 DEA data, list of length 9. There are inputs, outputs, DMU names, NC inputs, null, NC input, UD output, UD inputs. UD are undesirable inputs and outputs. We do not have any undesirable inputs and outputs in our data, so we have not specified those. Okay. Once you have done this, now you need to run the model. The model we are going to run is CCR model, and it is called basic model in DEAR. I would also like to save the results of running this model. So results CCR, let me create this new data set, and what I will do is this model underscore basic. You can see that there are many other models available, for example, additive, super efficiency, basic, DF, FTH, but for now we are going to run the basic model, which is CCR. Okay. Basic model. Now I need to tell this on what data to run it. So the data we want to run it on is CCR model. Okay. Now I need to specify some of the things, which are its orientation is input oriented. It is input oriented. Okay. And return to scale, RTS is constant return to scales, CRS. So you know, as I told you, CCR model assumes a constant return to scale. Then I also need to tell it how many DMUs I want to evaluate. I have 10 DMUs, I can evaluate all of those, or I can choose to evaluate less than 10 DMUs, but I will like to evaluate all 10 DMUs. So in DMU evaluation, I will write 1 to 10. Similarly, for DMU reference, I will also write 1 to 10. 1 to 10. Once I do that and run this piece of code, you will see that something happens and a new list of 15 variables, result CCR, is created. Okay. If you open this, you will see that a number of things are available in it: DMU weight, cell, U data, DMU evaluation, DMU reference. If I print this result CCR, let's see what happens. Oh, quite a long list of numbers is there which I really don't know what these are. So this is not the way to do it. I can extract single parts, various parts of these results. For example, I can evaluate efficiencies of the various units. For that, I will use the command efficiencies from results CCR. Okay. When I do that, I can see that my DMU number 1 is 0.9234 efficient. This is 0.7, 0.73, 0.93, 0.52. This DMU number 6 has the highest efficiency, 1. No unit can has more efficiency than 1. DMU 7 is also efficient, and it has an efficiency score of 1, whereas DMU 10 is also efficient and it has an efficiency score of 1. So I can see that 3 of my units are efficient and other units are inefficient as compared to these most efficient units. Okay. But that's not all I am looking for. I mean, what purpose does it serve to just know that which units are less efficient or which units are more efficient? I also need to see what level of inputs and outputs I should be targeting for every DMU. For that, I can extract targets from results underscore CCR. Okay, now I made a mistake. It is not results underscore CCR, it is result underscore CCR. Okay. Where I run that code, this gives me that for unit 1, I should be targeting input 1 to be 18 point something, input 2 should be 10.15. Okay, similarly for outputs, I should be targeting an output of 22.788 for DMU 1 and for an output 2 of 30, value 30 for in DMU 2. Okay, this is also a bit hard to understand and read here. It would be quite easy for us if we can have these values in an Excel file. To do that, you can choose to save this result. For example, I can score efficiency, and then I use efficiencies from result CCR and save it as EF. Then I write CSV, okay, and write CSV what? EFF, and I want to save it as EFF dot CSV. Okay, now when I go to my working directory, I will have a CSV file of efficiency.csv. I can open it to see the efficiency scores of various DMU units or DMUs. Okay, so here you can see that I have DMU 1 is this much efficient, DMU 6 is this much efficient, DMU 8 is this much efficient. Okay, so I can always extract these results in an Excel or CSV file, or I can choose to do something even better. That is, I can extract all of these results and save them in an Excel file where it would be much better to see and interpret and evaluate those results. To do that, we use function summary. Summary result CCR. It not only dumps it in the console, okay, it shows all the results here. If you go to your working directory, you will see this new file, result DEA21 something. You can also specify the name of this file, but if you do not specify any name, it will always come out like this, results DEA21. It will have date and time. Okay. Now let's open this file to see what it contains. You can see that it has many worksheets, which are efficiencies, slacks, lambdas, targets, returns, and references. For now, we are only interested in these two worksheets, which are efficiencies, which give us the efficiency score of every DMU, and I am interested in targets, okay, which tell me which unit should target what level of inputs and outputs to be efficient. Okay. So this gives me, for example, if I want my unit number 2 to be efficient, the best combination will be to have this much of input 1, this much of input 2, this much of output 1, and this much of output 2. So this is the optimized solution. Okay, fine. I can also do something else, that is create a plot. So for that I will be using plot result CCR. Okay. Oh, this gives me a plot which I can choose to zoom. This tells me that 3 of my units are efficient while 7 of my units are DMUs are inefficient. Then it gives the distribution of the efficient and inefficient units. I can see that one of my units lies in less than 0.6 efficiencies, while this many units are in from 0.7 to 0.8, and these units are in most efficient region. If I press enter, it will give me a new graph. Okay, this is what is this graph about. Let's see. This graph tells me the efficient DMUs and number of times appearing in the reference set. I mean, for the evaluation of various units, this DMU number 10 appeared 7 times. That means it is the reference point for 7 other DMUs, while these two are for reference for 4 units. Okay. I can press continue to see another graph which is quite interesting. If you zoom this out, okay, you will see, zoom this in actually, not out. This is DMU 7, this is DMU 6, and this is DMU 10. So you can see that 7 arrows are going towards this DMU 10. 1, 2, 3, 4, 5, 6, and actually a 7th one which is not quite visible. While this is 3 arrows are going to this and 4 arrows are going to this. Not actually 3, these are 4 arrows also. Okay, what is the importance of this graph, or what is the importance of knowing which unit is a reference point for which other unit? Because if I want to, I know that this unit DMU 10 is most efficient. It has the efficiency score of 1, which is the highest possible efficiency score. If I want to improve the efficiency of this number 5, I should probably be looking to this unit for benchmark or this unit for the benchmark. Okay. If I want to similarly, if I want to make this unit efficient, I should be looking to this unit for comparison and benchmarking, and for this unit to okay. There will be some units, for example, this to improve this unit, you should be looking to unit number 7 and unit number 6. So that is the importance of these graphs. Okay. So that is all. That is how you conduct DEA or data envelopment analysis in R using the DEAR package. Okay. To practice, DEAR package has a number of data sets in it. Okay. You can see those data sets by writing the command data in package is equal to DEAR. Okay. This will give you the list of data sets it has. You can access these data sets, okay, Ton 2003, Limzo, etc., etc. For example, if I want to see what is this coal Belasco 2006 data, I can simply write DEAR, okay, and this coal Belasco, okay. If I press enter, it will show me the data set. I can choose to save this data set in, say, coal ball, okay. I can choose to save this data set, and to do that I will again access from DEAR and save it. As soon as I do that, you will see a new data frame here with the name coal_bal. Then I can do my calculations and my analysis on that data set. So that's all. In next videos we will discuss more advanced models of DEA.